I'm Mr. Precella, and today we're working on homework number 13, lesson 13. We're looking at operations on functions, difference quotients, and composition of functions. And
it's a continuation of this discussion of functions that we started the last, well over a week ago, or at least a week ago. For every x value, there can be only one y value. Function is a rule which assigns to each x value exactly one y value.
Okay, switching over to the document
operations, we normally think add, subtract, multiply, divide. Does someone ask you what are the operations on the real numbers? Say add, subtract, multiply, divide. And so
those operations can be extended to functions. You can add, subtract, multiply, and divide functions. And operations, by that I mean addition, subtraction, multiplication, and division.
Division's going to be the hardest. Of course.
Not really.
He gets the joke.
Okay. But there's really no new algebra here with operations of addition, subtraction, multiplication, and division. Addition and subtraction of functions is just plain old algebraic addition and subtraction. Multiplication of functions is just algebraic multiplication. How do you multiply algebraic expressions? And division is simply division of algebraic expressions. So there's no new algebra here. It's just a matter of notation, and the notation is pretty obvious. To illustrate this, looking at number 1 from homework number 13.
This is one of those problems. I told them too many parts.
Yeah, and you get to type each, and they're going to have you typing in the domain for each part as well. They couldn't just have you do it all at one time. No, they're not going to do that. F of x, they give you two functions. F of x is equal to 5x plus 4, and g of x is equal to 2x minus 5. And you'll notice they're wanting us to find f plus g, f minus g. Look at this one here, fg. I don't even see a symbol there. If you don't see an operation, what do you assume it is? Multiplication, so we're multiplying f times g. And then they're representing division with a fraction bar, f divided by g. So let's get started. Let's switch over. There, okay, so I wrote down my two functions, and we're going to get started. Why don't we go through and do all of the parts, do the entire problem, and then we'll go through and type in all the answers, okay? Let's do all the problem, get all the answers, and then type them in.
Well, at least we'll do the f plus, f minus, f times, f divided.
Yeah, that's good thinking. First of all, f plus g of x.
Sometimes students start thinking, we got to distribute, multiply, and x. No.
No, that is not this notation. To add functions, all you really do is take the first function. You can think of it as taking f of x and then adding to that g of x. As a matter of fact, that statement right there, that obvious statement, is the definition of function addition. You take what we had for f of x, 5x plus 4. And notice I'm enclosing 5x plus 4 in parentheses. That's trying to show that everything there is f of x. And we're going to add to that g of x. G of x is 2x minus 5. And before we started class today, if I'd given you binomial plus binomial, you would have known what to do here. You know, I have parentheses here. There's nothing in front to distribute. That's just an unnecessary set. You can just drop those first parentheses. That's just 5x plus 4. we have that second set of parentheses. Well, we've got in front, what's in front of it? Just a plus? That's like distributing through a positive 1. Is anything going to change? No, so that just stays a plus 2x minus 5. These things are called, the parentheses I put there are both unnecessary parentheses. Now for f minus g, I bet you we're not going to have 2 unnecessary parentheses. Let's see, but let's finish this one. And now you know, I said that addition of functions is just plain old algebraic addition. You know how to add these. It's combining like terms. What do you do next? Okay, 5x plus 2x. Those are like terms. That's 7x. And I agree. 4 minus 5 gives us a minus 1. So there's my answer for f plus g.
Ask yourself, what would you do differently if that green plus had been a green minus? And if you know that,
then you'll know how to subtract functions as well. As I said, addition, subtraction, and multiplication of functions is nothing more than just algebraic addition, subtraction, multiplication, or division.
I'm thinking that in the past, on the second test, there's you don't have a part of a question on a test with this many steps or this many parts. So I think that the f minus g is frequently wrong on tests. People miss it because what do they not do with that minus?
So, okay, we know f of x. Once again, we're still using the same f of x. So that's 5x plus 4. But we're subtracting, so a minus. And g of x, we know g of x, that's 2x minus 5. The first set of parentheses, unnecessary, there's nothing to distribute there. We could just drop them. I didn't even need to write that first set. But what am I going to have to do? You have a set of parentheses with a minus in front. And that's going to, now realize inside the parentheses, you don't see a sign on that 2. So that's a little positive 2 and a minus 5. What are the signs going to become? Negative 2 and a positive 5. I agree. And now it's just a matter of combining like terms again. 5x minus 2x gives us 3x. 4 plus 5 gives me, for my final answer, of 3x plus 9. Any questions there?
To add fractions, functions, you combine like terms. To subtract, what do? You distribute the minus
and combine like terms. Function multiplication is just plain old algebraic multiplication. So f times g. You're going to have to take your function f of x and multiply it by your function g of x.
And that's the formal definition.
That's the formal definition of multiplication of functions.
Which seems mighty
obvious. So we know f of x is 5x plus 4. As I said, for addition, subtraction, multiplication, and division, there's no new algebra. It's just a matter of notation. And then g of x is 2x minus 5. If we had come in here today, before class started, one of my favorite things to do is to come in and just give a little pop test right at the beginning of class to see how, whether you're ready for the lesson or not. And if I'd come in and given one of my world famous pop tests, and this was on it, what would you do to multiply that? I would never give a pop test. Yeah. Never. In my 30 plus years of teaching experience. Now I was just saying that to scare you. Never.
Okay. I got to do something I didn't like as a student. And I didn't like, just like, I was later on Monday after spring break, or better yet from the reviewing for the test, I'll be walking around having certain people, and they'll have to come up and work the problem. I would never do that. I didn't like a teacher to do that as a student. I don't call students up to the board. Why? Well, what if they mess up? Okay.
That could be embarrassing.
Yeah, and either way, I mean, why do you,
Let's get back, Tony.
Yeah.
I thought you said we were going to get through early today. Okay, I'm waiting for y'all to tell me.
They've already said 4.
Oh, you did? Okay, so first, 10x squared. Remember, x times x becomes x squared. Outer. Minus 25x, I agree. Plus 8x, there's the inner. Okay, and positive 4 times negative 5, I agree with that. Minus 20. And that gives me, combining like terms, we have 10x squared, negative 25x plus 8x, negative 17x, and that minus 20.
To do this division, you're probably going to need another sheet of paper.
Just shrink it down some, Tom. Okay, just shrink it down there. Any questions on multiplication of functions? Multiplication of functions is just algebraic multiplication. Now division. Division of functions.
This is going to be the hard one.
F divided by G. Okay, there's your fraction bar. I haven't stated the formal definition of division of functions because it should be obvious. What do you think I'm going to have on top? F, that's right, F, 5x plus 4. What do you think we'll have on bottom? Okay, 2x minus 5. Now, this is a rational expression. If we could factor and cancel, that'd be great. We do that. But both of these things are linear. There's no x squared. Can we factor either of those? No? There it is. There's the final answer.
Just F over
G.
And now we'll start typing in these answers.
Okay. And Tony, while you type in those answers, I'm going to go and
walk around the room and choose the next
people to put problems on the board.
Okay. 7x minus 1. Oh. Tim, your microphone is on, so we can hear you whispering over there. What was F minus G? 3x plus 9? F times G. Ooh, okay. Now, when you type in messy stuff like this, remember, never hit the space key. 10x squared, right arrow to get out of that exponent, minus 17x minus 20.
Okay, what do you think you're going to type first to enter in the F divided by G? The fraction bar, yes.
It's easiest to do this first, yeah. Hit that, and then 5x plus 4, go down to the bottom, 2x minus 5, 20 short years. We'll be finished.
Okay, now we need to discuss the domain. Switch back to the camera, Tony.
And we stated a rule about domains that said if there's no fractions and no square roots, what's the domain going to be? Do y'all remember?
Okay, so the original function, we know that domain is negative infinity to positive infinity. Likewise, for G, negative infinity to positive infinity. You really shouldn't just look at the final answers in order to determine the domain of the sum, difference, product, and quotient. What you should do is you should look through all the work, looking through your work. I don't see, for F plus G, I don't see any square roots, so I can't get imaginary numbers. I don't see any fractions, so I can't get undefined results. Once I see that none of those things appeared throughout the work, what do I conclude the domain of f plus g is? That's a linear function, a diagonal line. The domain, all real numbers. Do the same thing for f minus g. Do you see any square roots or fractions? No. So what do you conclude about the domain? All real numbers again, I agree.
And all real numbers is just another way of saying this
negative infinity to positive infinity. F times g, looking through here, what do you conclude about the domain? All real numbers.
I'm going to go ahead and put those in right now.
Okay.
Because for f divided by g, well, there's no square root, but there's a fraction. So that's going to take a little bit more work. So let me start putting these in. I'll go parentheses, negative infinity, comma, infinity, close parentheses. And I'm going to copy and paste here. Control C, so I don't have to type it over and over. And then Control V. So F plus G, F minus G, F times G. Domain is all real numbers. Now this F over G, that's going to take a little bit more thought.
But not that much. Well, first of all, would this can you switch back? Would f divided by g create any imaginary numbers? In order to create imaginary numbers, what symbol do you have to have? A square root? You don't have a square root, so you don't have to worry about imaginary numbers. What about undefined results? When is an expression undefined? Did Tony show you this? A number divided by 0. What does that say? No, you can't do that. That's undefined. So we don't want a denominator of 0. That means 2x minus 5 cannot equal 0. So you solve that as if it's just an equation, which means you do what? Move over the 5, I agree, to get that 2x can't equal 5. And then divide by 2 to get that x cannot equal 5 over 2. So the domain is all real numbers except 5 over 2. It can be any number to the left of 5 over 2, any number to the right of 5 over 2 on the number line. The only number that x can't equal is 5 over 2. How do we say that using interval notation? What did you have them do, Tony? Did you
I
have
would
them
just draw the number line.
Okay, so there's 5 over 2.
What means not including? Open or closed circle?
Open circle, but it can be anything else. So shaded over here. Shaded over here. So I'll write out the interval on the left, and y'all tell me how to write out the interval on the right. On the left. Oh, well, y'all are telling me negative, you're doing it there. Negative infinity to 5 over 2, and what goes in front of a negative infinity? Parentheses, right, okay. What goes after this 5 over 2?
Like bracket or parentheses?
Parentheses, because it's not shaded. Union 5 over 2 to infinity. What's going in front of the 5 over 2? Parentheses. What goes after the infinity? Parentheses as well.
Oh wow, we almost through with problem 1.
Yes.
20 short years, we'll get finished with this assignment. Oh wow.
To me, it's a problem that I said there's no new math here.
But it sure
It sure did take us a long time, didn't it?
In parentheses, negative infinity, comma, 5/2. Be careful, don't do that.
What do you need to do before you?
I need to, oh wait, let me see, what did I do wrong? Don't do that, okay? It'll count it wrong. If you put that parenthesis in the bottom of that fraction, so let's type 5/2, I'll hit right arrow, parentheses. Here's the union. If you ever find yourself clicking on the intersection key, this little key here, you're doing something wrong. Every time I come to work, I drive past streets I've never been down. So you just got to know, ignore that. So this little intersection key is there, but you better just ignore it. Right arrow to hit my comma, infinity, parentheses. Okay. Oh, wow. Okay. That took a while, didn't it?
Any questions there?
Oh, my goodness, Tim.
What?
Is it not recording? Oh, let me see. I think it is. I think I just messed it. Yeah. Oh, my gosh. 21 minutes on problem number 1. Okay.
I thought you said you'd get through early today, Tony.
Well, I thought we were coming. Any questions on that? It's not hard. It's just time consuming.
Okay. Now, second big topic in this section. There are 3 big topics, okay? So
before you begin that second big topic, I want to review something real quickly. If you have a function like this, f of x equals 3x minus 7, and then there's a number, it says find f of, let's say, 5. Do I remember what to do if there's a number in here? You plug it in for x, yeah, so it'd be 3 times 5. What is that, a 15 minus 7, 8? Well, a week ago we also had some problems like this. Suppose there's not a number, but some variable. That's a p there. To find f of p, well, whatever's in the parentheses, you plug in for x. It doesn't matter how bizarre it is. If you were trying to find f of, let's say,
C plus D.
C plus D, that's a good one. That one's going to take a little bit more work. To find f of C plus D, in place of that red x, what am I going to put? C plus D?
And then distribute.
And you have to distribute the 3. So we'd have a 3c plus 3d minus 7. So just, in order to do this next problem, you've got to remember how to work with this function notation. Whatever's in the parentheses, you plug in for x. So I'll let you get on with number 2 now. Three-step or a 3-part problem.
Okay.
So on to problem number 2.
First of all, there's something called the difference quotient. It's important in a calculus environment for the definition of derivative. For our purpose, it's just an exercise in using function notation, okay? But the difference quotient does have, as an important component of the definition of derivative.
Yeah, and y'all remember rise over run for slope of a line? That difference quotient is how you're going to measure the slope of a curve if you ever take a differential calculus course. But we won't be doing any calculus here. We're just doing the algebra part of it. And this part right here, part C, is what's called the difference quotient. Difference means subtract, and quotient means what?
Divide.
What operation? Divide?
That's
right. What's called difference quotient. Subtraction on top and division. Okay? But we're going to break this up into 3 parts. Let's look only at step 1 first.
Okay, well, first of all, number 2 from homework 13. F of x is 7x, f of x is 7x, not 7x squared, just x squared plus 7. So, part A, notice what we have in the parentheses. They want us to find, in part A, they want us to find f of It's not C plus D, it's what? X plus H. Let me switch over. Okay. That f of x plus h, that's that first part in the numerator of the difference quotient. Remember what we were saying. We said that whatever's in the parentheses, you go and you plug it in place of the variable. So f of x plus h. That's saying come up here to f of x, and whatever's there in place of that x, we're going to replace it with that x with x plus h. I agree. Well, there's some simplification here. Maybe
as easy as you think. It's not just x squared plus h squared. What are we going to have to do? You've already said this four-letter word once.
Foil. Remember, you had a problem. You had some problems with the complex numbers.
I'm sure they remember probably number 5 off of
homework number 2. Yes. Well, I've been gone for 7 weeks, and I remember it, Tony. So they remember it too, I'm sure. Remember if we had a little complex number squared, you had to write it twice and foil it out? That's what this thing is. X plus h squared.
So this is
that's saying x. Here's my scratch work. X plus h times x plus h. So we start foiling. First, we're simplifying x plus h squared. We had to write x plus h twice and start foiling to get me x times x first.
They don't know they're supposed to say x squared.
X squared, oh, okay. Outer x times h. Here's what I'm going to do. If my term has 2 different letters in it, I'm always going to put those letters in alphabetical order. I'll tell you why in a moment. X times h, that's an hx. Inner h times x is another hx. And notice, now I've spotted I have 2 like terms here. If I'd written that as an xh, and this is an hx, we may have not spotted them as like terms. Like terms have to have the same variables, and if they're in the exponents, they have to have the same exponents. But hx and xh are like terms. So to make sure you spot them, just always put the letters in alphabetical order. Last, we're not through foiling yet. H times h, I agree with h squared. So combining the like terms, that's x squared plus 2hx plus h squared. And there's my scratch work. This was my scratch work here. I'm boxing it off on the side, okay? So there's my scratch work.
Now part A is the lengthy part of this.
Part A is the lengthy part, okay, as we'll see in a moment. So we know x plus h squared. We've already foiled it out. It's x squared plus 2hx plus h squared. And we still have what stuck on there? The plus 7. So there's the answer for part A. We're going to have to go and type that in. So going back.
X squared, right arrow, plus 2hx plus h squared, and then, I was about to do this, plus 7, in which case I'll get it wrong. No, that plus 7 should be up there in that exponent. Right arrow, plus 7. Yeah. When y'all first saw subtraction in elementary school, was it like take away? Is that how they worded it? 5 minus 3, you had 5 apples, take away 3 apples, what's remaining? Well,
this minus right here, the minus between the f of x plus h and the f of x. That minus is going to work just like the old-fashioned takeaway. You should be able to get, if you understand what they're asking you to do, you should be able to get your answer to part B without showing any work. This is saying...
But you feel like you've got to write something.
Yeah.
But you should be able to just sort of look at it and get that answer.
This is saying, take what we just found, f of x plus h, what we just found, and take away the original function. So we have an x squared, take away an x squared. So x squared minus x squared is gone. What else is gone? The 7. Here's a hint for part B. The only terms remaining must contain the letter h. Anything that doesn't have an h had better subtract off.
But let's suppose you didn't. Let's suppose there wasn't an x squared for you to subtract. Then you messed up.
Then you messed up.
Okay? You take away the x squared and you take away the 7.
Everything that doesn't have an h should appear in the original function. There's the answer for part B. And notice this is
why not write part A, take away original function.
Take away
right.
Original function. Okay, so part A, take away the original function. Just remember for part B, f of x plus h minus f of x, you only have the terms containing h remaining. So let's go type in that answer.
Oh, what was that answer?
2hx plus h squared.
Plus h squared.
And finally, part C. This is the actual difference quotient. We're finally ready. Can you switch over to my camera for me?
Oh.
We're finally ready to get that difference quotient. You have
all of this is part B.
The top of it is part B. You know that. It's 2hx plus h squared. And we're going to divide all of that by h. I just said the numerator always has, every term up here on top has to have what letter? H. So there's a common factor of h. Factor the h from both terms. Factoring out an h from the first term, you get 2x plus, you're taking out one h, you had two h's, okay. And then what happens with those h's? Cancel to give you 2x plus h. Is that how you do it, Tony, or do you split up?
Normally I split it up. Once I have this, I just put each one of these over.
I don't split up unless there's an I on top. That's my rule. Otherwise, that always makes sure that in a multiple choice environment, your answer looks like what they give you. The correct answer looks like what they give you. Any questions there? Now, suppose they had just told me, find the difference quotient.
Yeah, like number?
Like, suppose they had just given you part C.
Yeah.
I still break it into 3 different parts. I still break it into f of x plus h. I do that first. That's always the longest part. Then I take away the original terms. The last thing I do is divide by h. So even when they don't tell me to break it into 3 steps, and when I'm teaching my business calculus class and we're working with that definition of derivative, and we're simplifying a difference quotient before we start looking at the limit as h goes to 0, I still break the difference quotient into 3 steps. And so that's what I encourage you to do. So for number 3,
why don't we color code it? We'll write down the problems.
Okay, yeah, let me do that. Okay, this is number 3. from homework 13. And the function,
8x squared plus 8x plus 7.
Okay.
And now, why don't we do it like this? The f of x plus h will be in purple. I know y'all can't see that yet. Then the minus f of x will do in red.
And it's all at an angle.
Oh, I didn't know you switched it over. I was just writing it up. Okay. Here. So we'll do the f of x plus h in purple. Then the minus f of x, that's the real easy part. You just mark out the 8x squared, mark out the 8x, and mark out the plus 7. And then the divide by h is easy.
That x plus 8, f of x plus h, let's do that first. That says come up here to my function f, and wherever I see a variable, I'm going to replace it with x plus h. I agree. So I'm replacing the variable here with x plus h, and that second x I replace with x plus h. Oh, shoot. You see, I view myself as an optimist because no matter how bad things are, and they've been bad for me the past year, and I always think things could always get worse. Things could always get worse, and it seemed like for a while invariably they were. But someone told me that if you think to yourself things could always be worse, that really means you're a pessimist. No, I don't think so. And so here's the lesson for this, the reason I'm mentioning that. Suppose that had been a cube. Now I'm here grumbling because it's an x plus h squared. Suppose it were a cube. When we were foiling it out, we'd have another x plus h. We'd then have to distribute another x over the x squared plus 2hx plus h squared, distribute another h through that, and if my mental multiplication using the binomial theorem is correct, we would have gotten an x cubed plus 3hx squared plus 3h squared x plus h cubed, okay? But most people wouldn't be able to do that in their head the way I did it, okay? But they're not going to give you a cube here. For these difference quotients, they're not going to give you anything other than squares. And so, yeah, you got to write it twice and FOIL it out, but things could always be worse. Suppose they'd given you that cube, and you had to then distribute through another x plus h. They're not going to do that to you, okay? So that's a good thing, right? Y'all don't seem to agree. Are y'all thinking about spring break? Do you already have your mind on spring break?
No, spring break's only a week. Don't forget that. Okay? Sometimes students get confused. They think it's a couple of weeks. Or 3 weeks, worse yet.
Hey, look at this. X plus h squared. I have it right there. But what have we got in front of that x plus h squared? An 8? What are we going to have to do? I can't believe I'm stooping to this laziness of just using my work from the other problem, but that's the advantage of writing it on paper. It's not erased. I can use what I just did. Do you think this is setting a bad example, Tony?
Well, your laziness never ceases to amaze.
Yeah, as I stoop to new heights of laziness. Okay, so any questions? Y'all remember how we squared the x plus h's, right? Now we have that 8 in front of it. What's that going to give me? 8x squared, I agree. Keep going. Okay, I agree. 8 times 2, that's a 16hx. Keep going. Plus 8h squared. Uh-oh, what about this? To give me? Let's get rid of those parentheses.
I'll go ahead and distribute that 8 right now.
To give me an 8x, I agree. Plus, don't forget that 7. And that's the long part. That's the long part of the problem.
The rest of it's going to fall out really easily.
And this is nice because we don't have to type in this messy answer there, okay? They're only wanting the final answer. So we take what we just found and we take away f of x. Which of these terms are going to be taken away? 8x squared minus 8x squared, okay. The positive 8x minus 8x, that's gone. Anything else? The 7 minus 7. Remember, I said the only terms that are left must have what letter? H. So we have 16hx plus 8h.
And now if I can show them how I do the over h.
Yeah. Divided by 8.
Oh,
why'd I do that? Oops, I didn't.
I make 3 separate functions and just...
Yeah, I messed up.
Okay, well, do it your way, Tim.
No. Okay, you see what he was going to do was take the 16hx, put it over the h.
Yeah, I just put them each over h and cancel like that.
And what cancels here?
One of those. And it looks like a big mess.
But it is, I think it's probably quicker than factoring and canceling. Did y'all follow what he did? Just put each term over h. And that'll leave us what here? 16x, I agree, plus here, just an 8h, plus, oh no. Make it smaller, Tony. Just make it smaller so the whole problem fits there. And what else? Plus 8. I agree. That's all we have to type in at this point.
Mm-hmm. Yeah, that was a good thing that they didn't break it up, part A, part B, part C.
I still break it into 3 parts for my work. But now at least I don't have to type in all those other answers. All I type in is the final answer. Switch them back to MyLab. We type in 16x plus 8h plus 8. Any questions there? What could we do? I guess we could factor an 8. We could factor out an 8. This is a common factor, but I think that's all. Switch back. Okay. Yeah. You could say, okay, 16 and 8 are all divisible by 8. So you'd have a 2x plus h plus 1. I'm not sure whether MyLab would take that.
I don't
think they would.
I think they want it written without any parentheses.
Mm-hmm.
Okay.
I don't think MyLab would take that. But you can play around with it and report back after spring break, okay?
That'll be your spring break project.
Okay. Any questions? Addition, subtraction, multiplication, and division are all operations on real numbers that can be extended to functions. There's a 5th operation that applies only to functions called composition of functions.
And just like addition has that little symbol, subtraction has a symbol. Well, for real numbers, you might use an X for multiplication and a fraction or the little division symbol. This new operation called composition of functions has a symbol, a little circle.
Okay, here it goes. F composed with the g of x is defined to be f of g of x. They're using that little O for of, I suppose. They needed a symbol. They wanted a symbol to represent the operation. I guess that was a pretty good symbol. And to make sure you understand that notation, suppose f and g were reversed. G composed with f of x. That's saying g is on the outside and f of x is on the inside. And my brother has a nice way that he illustrates this in his example. So I'm going to step over here.
And I think the first problem doesn't have f in it. Or maybe no g. It has the functions f and h. Okay.
So let's write this one down. This is problem 4. F of x is 5x minus 1. And g of x, no, h of x, is that a negative in front of that x?
Is that better? I made
Plus
it
2? It's just so bizarre, and I think I told Pearson this. The one problem that should have more than one part, they have one part to it. It says find h of f of 3. Notice how you just, if you want to read this formally, you read that little circle, it's just the word of. Or
But that's not multiplication.
No.
In
Or
other
you could
math
say,
classes, you would have
it's
said
just that
of.
f of x,
Yes.
function of x. It's not multiplication. So, let me write this down. Looks like half. Is that a word, H-O-F?
Half? I don't think
Half
so.
3. Okay. What this
I
means...
better switch, right?
Oh.
Okay, there it is.
Okay. H of f of 3 means, start with this number in the parentheses. Plug this into that. Now, this fog x means g of x goes into f, and golf x, f of x goes into g. Gets plugged into. Let me see. Let's start off with f of 3. Start with the number in the parentheses. Plug it into function f. This is stuff we did right at the very beginning. Oh, not at the beginning, but this stuff here. And there's a number in the parentheses. You just plug it in for x. So start with the 3. Plug it into function f. And what are we going to have? 5 times 3. That'll be a 15 minus 1. Is that a 16?
No,
oh, my
it's a
gosh.
14.
A 14. Wow.
I'm just waiting to pounce.
Thank you. Okay, so you start with the 3, plug it into f, you get a 14. Now plug that into h. So over here is h. So we have a negative. In place of this red x, I'm putting that 14 and a plus 2. Negative 14 plus 2, is that going to be a negative 12? See what I did? In words, if someone asks you in words, tell me out in words what the heck you're doing here. You take the 3, plug it into f, take that answer, plug it into h. You're starting with the number, working to the left. Plug 3 into f, plug that answer into h. So go ahead and punch it in. They have more confidence that I'm doing it right once they see that it says it's right. No, don't go back to the, let's switch back here. Let's do this one. Suppose it had said f of h of 3. In words, how does this one differ from from the one we just did? Well, we start with the 3. We plug it into which function? The h. You plug 3 into h. Let's do that. We'd have a negative 3 plus 2. What are we getting there? Negative 1? Yeah, I agree. Now what am I going to do with that negative 1? Plug it into f. Okay, so we have a 5 times negative 1. I guess I could have just done that without showing that step there. And then a minus 1. So in place of that blue x, I put a negative 1. So is that going to be a negative 6? Negative 5 minus 1, negative 6. So in words, you take the number, plug it into the function beside it.
The inner function, the one that's on the inside.
And then take that answer, plug it into the one. You're working from the right to the left.
You plug it into the inner function.
and then the result you get, you plug into the outer function.
Mm-hmm. Now,
are you ready to do another example?
Well, I'm ready to go on to number 5, except
you want to give a little pop test?
Yes.
Yeah, let's give a little pop test.
Okay. But only to 7 people that will randomly choose.
And they'll go to the board and work the problem?
Yes.
Okay, I like that.
Okay. Go on to the next question, but
don't write this down.
Immediately. Oh, well, good. It's not showing. This is tables. Make it smaller.
Oh, yeah.
Minus, yeah.
Yeah.
Okay. I think that I have another number 5 that I've made up. Let me switch over here. Here's the number 5 we're going to do.
So don't write that one down, okay?
We'll do it in a moment, but I think this one
is better.
We have some little function tables. And there's going to be 4 parts to my problem. To the Pearson one, there will only be 1 part. And it's a terrible problem. The Pearson one.
Make sure y'all remember working with functions. And this is saying, with the little table, that's saying the function f. 3 is assigned to what number? 7. 9 is assigned to what number? 2. Using the G table, -5 is assigned to 3. Okay, so y'all remember? It's just ordered pair representation, basically.
That's why a function is a rule which assigns to each x value exactly 1 y value. So those f of x and g of x, those are the y value. So instead of plugging into a formula like we did on problem 4, we're looking at the table, and there's not a lot of scribble here. Okay? So you sort of have to follow what I'm doing to find that fog 9.
This is one of those times where the little PDF really wouldn't help to understand what's happening. I have to hear what you're saying.
Because there's not a lot of writing. There's Mario talks, a friend of ours used to be a butcher. Turns out now he's not a butcher. He's premier edible artist in Houston, but he...
I don't know why I'd watch our videos and he'd talk about how we scribble. I was just talking hands. It scared him. He said the fact that it was like the hands were talking because he never saw the person.
But he would talk about 2 different types of work as a butcher. There was the physical work where you unloaded the truck. That was a physical work of being a butcher. And then there was the other type of work that wasn't physical. It was up here, the pricing the meat and all of that. And he said he'd rather do the physical work any day of the week. That was easier than the up here in his mind work. Well, here, this one's just sort of in your mind. You start off, I'm doing fog 9. By the way, do not say fog. If you're taking Calculus 1 and they're looking at the chain rule, don't talk about fog and golf. And if they do, and they say, who was your algebra teacher? You say T. Precella.
No.
T. Precella.
He says that fog and golf because he knows it annoys me because it reminds me of a graduate professor we had that would say that. And it was just too serious a class for that levity of fog and golf. What was he doing saying fog and golf in that class?
At the end of the semester, if someone says, did y'all do composition of functions in your algebra class?
I never say that.
You're going to say,
golf.
I don't know, but if they say fog and golf, did you do fog and golf? Oh, yeah, I remember that. Okay, so fog 9, f of g of 9. I start with the 9.
Even I've forgotten what we're doing, Tony. You're rambling too long. Do the problem.
Start with the 9.
You promised we'd get out early today.
Start with the 9 and look at the G table. What's G of 9? G of 9 is 7. Now look at the F table. F of 7 is... What number will I write here as an answer?
They already said 4.
Oh, they did? I didn't hear anyone say 4. 4? Now, compare that. Suppose we reverse the G and the F. G of F of X. First, look at the...
Which table do you use on this one? G composed with F. Which one do you use first? The F table or the G table? No. What do you use first?
Sorry, F.
The F table.
Okay. This one. F of 9 is 2. Now look at G of 2, and what are we going to get? 8. That's right. Now, take a couple of seconds and see if you can figure out the fog negative 5. See if you can get the right answer before I do it. Let's see. First, look at the G table. G of negative 5 would be the 3. And F of 3 is it 7?
Yes.
Okay. 7. And what about that last one? Oh. Is the last one going to be 7 also? Oh, well, that's a G of F of negative 5.
Wait a minute. I pounce. The person that's never wrong, when he makes the mistake, here's a good teaching technique. Any future teachers? Has Tony taught you all this technique? You wait until the person that's never wrong, when he finally says something wrong, you pounce. Okay? And so I'm pouncing. Let's go. I think
G of F of negative 5.
So F of negative 5 is
2.
G of 2
is
2 goes to 8, not 7.
Okay. Y'all sort of see how I'm doing that? Because there's not a lot of writing there. You know, I'm sort of circling and stuff, but
if y'all understand that, y'all will be able to just tell me the answer to this one, okay? Can y'all see that? Is that big enough? Do I need to make it bigger?
I think if you make it any bigger
than the tables aren't going to. So, what table will we use first here? Which one will we use first? F or G?
It's the only table that has a 10. That's what's so wrong with this problem.
So, G of 10 is 9. And then what do you do with the 9? You go to the F table. 9 is assigned to 6. I agree.
And instead of going on, let's say similar problem and do another one just so they can make sure.
What do they want here? Wait.
Oh, wait.
Oh, yeah. We want F composed with G of 8. So, what do we do first? Okay. G of 8 is 6. I agree. And then what do we do? F of 6 is 9. Okay.
And it's this 9 that's the answer. Okay, that 9, put your cursor there, Tim.
It's this 9 that's the answer, not that 9 there. This 9 is the answer. Y'all agree? Okay.
Now, let's go on and do number 6.
So, functions, you express functions 3 different ways, if I remember correctly. You expressed functions with an equation. That's how you do it most frequently. And then you express functions using tables and ordered pairs. Oh, I missed number 6. Oh, here's another one.
Yeah, I know.
This is a good one.
Okay.
Let me ask you this. What function, we want F composed with F of 6. Which function is the outer function? In this notation, which letter is the outer function?
Well, F.
F. What's the inner function? What are we going to be doing with G?
Nothing.
Nothing.
You don't need that G table. I'm not even going to write it down.
All you're using is the F table.
It says find far.
Oh, wait. Let me switch it over.
6. So I just wrote down the F table. You didn't need the G table. It's one of those streets that's there that I never drive down, but it's still there. They gave you G. You don't need it. There's not a lot of scribble to write out here. F of 6.
Okay. What do we do first? Which gives us 9. I agree.
9.
And then, okay, F assigns 9 to 7. for our final answer.
So
Just type our 7.
And do similar problem.
Again?
Yeah,
They're
one
wanting to
more.
get out early.
Well, I wanted to get out early the last time, and you didn't want to. So, humor me. What's the answer to this one? F of F is 7.
8.
Is it 8? Yeah,
Let's
that's
see.
right.
Yeah? Okay, that vocal minority is right. 7. F assigns 7 to 5. Then F assigns 5 to 8. I agree. Okay, I think we're beating a dead horse. It's time to go on. A composition of functions at a number gives you a final answer. That's a number. All of these compositions, 4, 5, and 6, the composition has been at a number.
The numbers are in the number. There's a number in the parentheses.
Now, if you don't have a number in the parentheses, if you have a composition at a variable, then your answer is going to be a function of that variable, which means you're going to have. Here we want f composed with g of x. That means you're going to have x in your final answer. Your final answer is not just going to be a number by itself.
So
here goes. A composition at a variable
is 9x minus 10, and g of x is 3 minus 4x. Okay. It says to find fog x. All I'm doing at this point is just writing it down. And this is going to be my little arrow method for doing this problem. So how does this problem differ from the other ones? Make it a little bit bigger and slide it in. Well, like on number 4, there was a number. So you take the number, plug it into the function beside it, take that answer, plug it into the function beside it. But if there's a variable here, then that means plug g of x into f of x. So I'm plugging g of x into f of x. In place of this blue x, I'm going to put this red 3 minus 4x. So in place of the blue x, I'm putting the red 3 minus 4x. That's f of g of x, that fog x. Plug g of x into f. Okay? So these arrows, I'm just thinking, okay, plug this into that. And I can do a little simplifying here. What can I do? Distribute the 9. So we'd have a 27 minus 36x. And then we still have the minus 10. So let's see. What could I do? I guess I could say 17 minus 10. Excuse me, 27 minus 10 is 17 minus 36x. Or you could write negative 36x plus 17 if you would rather do that. The important thing is do not subtract a 17 and 36 and get a 19 or a negative 19. So 17 minus 36x. Let's plug that one in.
Any questions there?
Oops.
Now they want you to go the other direction.
Okay, and because I've already written those arrows there, I'm going to recopy the problem again. And I'm looking at
They want G composed with F. Wait a minute.
Okay, so I recopied f of x equals 9x minus 10, and g of x is 3 minus 4x. So let me see. Let me draw the arrows. This means plug this into that. So plug 9x minus 10 into the function g. So in place of that red x, I'm putting 9x minus 10. So we have 3 minus 4. And in place of the red x, I'm putting 9x minus 10. Are y'all following me? Are there any questions on what I'm doing? I'm plugging f of x into g. So I'm plugging the 9x minus 10 into this red x.
And what are we going to do next? There's only one correct next step. Distribute what? Okay. I want to make sure you didn't say distribute -1. Oh, you know, if you had said distribute -1, you know, I would have just pounced with glee.
Where is it getting the -1? 3 minus 4. Okay.
Order of operation says you multiply before you subtract.
So we have 3 minus 36x.
What else do we have? Okay. Not a minus, I think it's a plus 40. -4 times -10 gives us a positive 40.
That's a miscopied, which I might have.
Mm-hmm.
So what are we going to
get?
What am I going to answer? I think I'm going to write 43, the 3 plus 40, and then a minus 36x. And I'm writing it like that, even though negative 36x plus 40 is actually the preferred way. I just want, plus 43, I mean. I just want to make sure you don't decide to subtract 43 minus 36. Do not get a 7 there.
43 minus 36x. Operations are classified as commutative or not commutative. Addition is commutative. A plus B always equals B plus A.
Subtraction is not.
A minus B, it doesn't usually equal B minus A. Multiplication, is that commutative? Does A times B always equal B times A?
Yeah.
Yeah? What about division?
10 divided by 2 is not the same thing as 2 divided by 10. One's a fraction, one isn't.
Now, we have this new operation, composition. Is composition commutative? Does F composed with G always equal G composed with F? No. In most cases it doesn't. Occasionally it does, but those are special cases. Usually composition, F composed with G will not equal G composed with F.
So let's see number 8. All right.
Are we taking a break or are we going straight through, Tony?
Oh, y'all, we can be through by... y'all want to take a break? We could, or just go straight through and be finished by 10. Huh?
Go straight through? Now, if you have to go to the restroom or something, you feel free.
No, they cannot go to the restroom. I never let them go to the restroom. Or leave if they want to leave. Okay, number 8. I'm joking about that, of course.
You see, my moral, the story I told you all about how things can always get worse. And I warned you all that, you know, the elevator, we were laughing about the elevator being broken. And what happened at 11 o'clock on Monday? All the women's rooms here in building C, the women's rooms all backed up and stuff. And so the men's room was okay, but there was a real mess in the women's room. And so I went and scouted around. There are restrooms in building B. If you go that long walkway, that real long walkway, just walk to the end of the building, there are other restrooms here. So let's switch it. Anyway, but you see, things could always be worse. You could have the elevator broken, and you could have backed up restrooms. But remember what I said. What did I say about that? I said that when a building is new, everything works great. But once a building gets old, things break down. So, you know.
And the joke is it's really not an old building. Buildings that are only 7 or 8 weeks old are not considered old buildings. Now, this one, it's going to look like all I'm doing is drawing some arrows and writing the final answer down. And that's all I'm going to be doing. This f of g of x means plug g of x into f. So I'm plugging this red square root of x in for the function, in for that blue x. So we have a blue 4, and in place of the blue x...
What are we going to have beside that 4?
Yeah.
What are we going to have here?
What am I about to write?
The square root of x. Okay.
Plus 1. I'm replacing this blue x with the red square root of x.
Is that plus 1 under the square root? No, it is not. Okay. So, typing in.
And it looks like all I did was just write out the answer.
4 square root of x. What do I need to do before I type the plus 1? Okay, space over plus 1. Now the other direction.
G of f of x. Switch on.
Mm-hmm.
And this is one where it's going to look, all I'm doing is just writing the answer. G of f of x. That means plug G into f.
I think you said it backwards.
Oh, I'm sorry, plug f into G. I'm plugging f into G. So I'm plugging this in here. In place of that red x, I'm going to put the blue 4x plus 1. Notice all of this is under the square root symbol. Y'all see the difference there. I'm plugging f of x into G.
Say it again.
I'm plugging f of x into G. So I'm plugging 4x plus 1 into the function G. So in place of that red x, I have that blue 4x plus 1.
So what do I have to type first? The square root, yes. And everything is under the radical here. Everything is under the radical.
Oh. Any questions there? There's not a lot of writing to get these answers.
Now, Tony, you probably should have made a statement that you were joking about people can't use the restroom. Because this is being recorded.
Oh, I know I was joking.
But someone may hear that and not know it. And then you'd be called into your boss's office having to explain yourself.
Mm-hmm. Okay, so I'll remember that. F of x is a square root of 6x, and g of x is a 1 over x. So we're going to do fog x and golf x. Fog x. So let me lift this up. Let's see. In words, what am I doing? I'm plugging this into that. I'm plugging g of x into the function f. So let me see, I'm plugging all of this. So I have a blue square root, a blue 6. In place of that blue x, I'm putting the red 1 over x. And that operation there is times. So I need to do a little bit of multiplying. It's not hard. How do I multiply 1 over x by 6? I would think of that as 6 over 1 times 1 over x. What do I have underneath that square root symbol? Would it be a 6 over x?
6 times 1 is 6. 1 times x is x. Remember to multiply fractions. You multiply the numerators, multiply the denominators.
Good. Just multiply straight across. So that one had a little bit of simplifying there.
Okay, so we have the square root. Well, y'all tell me, what do I type first? The square root. And then what do you think I'm going to type? I'd use that fraction bar and put the 6 on top and the x on bottom. Good.
Oh, and now, because of the way I'm sort of messing it up with the arrows, that's why I recopy it each time. F of x is the square root of 6x.
While he's recopying, I want to point out something to you. If you look at the document sharing review for test 2, you'll see that within each problem, they're not going to ask for both. They'll only ask for one of them, f composed with a g or g composed with f. Knowing that their composition is not commutative, if they ask for f composed with a g and you give g composed with f, do you think you have the right answer? No. So make sure you know the order in which this operation composition works.
Okay. This means plug this into that. I'm plugging f of x into g. So I'm plugging f of x into g. So in place of that red x, I have a red 1 over. I have a red fraction bar. In place of the red x, I'm putting a blue square root of 6x. And there's nothing to simplify there.
I suppose you could rationalize. Remember, you did rationalize.
Oh, but you don't rationalize with variables.
And it wouldn't be you'd wind up with something a lot worse than what you started with. But
so type in 1 over the square root of 6x.
These problems here are excellent problems because there's not much algebra. It's really just assessing you on, do you know how this new operation works? I think they're great problems. Okay, here I am. I'm clicking in the box. What am I going to type first? The fraction, and then on top I have 1. What am I going to type in the bottom? The square root of 6x. Any questions there? And then which one?
10, just keep going. Okay. 12 and 10 and 11 are the last two of this new problems. 12 and 13 are just cut point review problems. So let's see. Number 10, we have f of x equals 4x minus 1. Oh, g of x equals a 1/4 parentheses x plus 1, and they're trying to find.
They want us to find f composed with g of x and g composed with f of x. Hey, look at this. They even ask us another question. Then determine whether f composed with g of x is equal to g composed with f of x. Well, normally, are they equal? If they'd asked us that on number 9, are they equal? What would the answer have been? No,
you don't get the exact
same you don't get the exact same thing. Number 8, the mere fact to me that they're asking are they equal makes me think this may be one of those exceptions. Remember I said usually they're not equal. There are some rare times when they are equal. This may be one of those rare times. Let's see. Oh, let me switch over. Yeah.
Okay, so let's see. This means f of g of x. That means plug g of x into f of x. So I'm putting all of this in for that. Ooh, it's going to be sort of messy. In place of that blue x, I'm going to put, and I still have that blue minus 1. In place of the blue x, I'm putting this red 1/4 and the red x plus 1. Now this operation here is times.
And remember, you multiply from left to right. So you said this is going to be messy. I think it's going to work out pretty nice. What's about to happen, y'all? What's going to happen to these fractions here? They're going to cancel out. Those 4s are going to cancel. So all you're going to have to distribute over the x plus 1 is what? He's pointing at it. What are we going to distribute?
a 1.
A 1,
So,
which isn't going to change anything,
yeah, I
is
think
it?
we're just going to have an x plus 1.
And what else?
The minus 1.
Okay.
So what are we getting as our answer here? Is it just x, the 1 minus 1? Y'all follow that? Looks sort of messy. And place it. This is some of the stuff that just looking at the finished product, what the heck are they doing? Okay. So looking at the...
Let's go ahead and find G composed with f of x, and then we'll type in the answer.
Oh, okay.
Oh.
Okay.
Let's box this in also so it's easy to spot it in a moment.
Oh, okay. And since I'm so close to continue number 10, I'm going to recopy the problem just so that I don't have all those arrows already drawn. F of x is 4x minus 1. G of x is the red 1/4 x plus 1. Which one are we doing this time? We've already done fog, so we're doing fog.
G composed with it.
Okay. We're doing this one. That means what? It means plug f of x into G. So could y'all draw the arrows? That would be putting this in right there. In place of that red x, I'm going to put a blue 4x minus 1. I still have the red 1/4. I still have that red plus 1 at the end. In place of the red x, I'm putting the blue 4x minus 1. And how is this going to simplify? What's happening with those 1s? Oh, y'all pulled
with
up?
the 1s?
Any questions? Y'all see what I did? I replaced the red x. I'm plugging f into G. So I'm plugging 4x minus 1 into the function G. And the negative 1 plus 1, those subtract out.
Something else is about to cancel out also.
What about this 1/4 times 4? Will those 4s cancel? Yes. So what are we getting as our answer on this one?
Just x. Well, look at that. What if f composed with G of x reduced to x, right?
Yeah, look at both of them round up with equals x.
Yes.
So let's go punch in those answers.
So f composed with G of x, everything canceled out except for x. G composed with f of x, everything canceled out except for x.
So x, and
are they equal? Yes, they are. This problem is trying to get you ready for inverse functions, which is homework number 15. And it would seem at this point I'd say, well, would it 14 on? Would it 14 and 15 next week and stuff? And so,
but
1 week's time. But no, because we have spring break common, we have the test 2 common, and so it'll be actually weeks before we get to homework number 15.
And by then y'all will have forgotten the XX yes problem.
And I'll come in and I'll show y'all.
Close that and say similar. Everyone's number 10. It's going to be XX yes.
X, because they're trying to get you ready for 2 functions whose compositions reduced to x in both directions are called inverse functions. And what's unique about them is they just reverse the ordered pairs x and y.
Oh, what I always say is they cancel each other out.
Oh yeah, they cancel each other out when they're performed consecutively.
And yes.
I say that too, Tony.
10 and 11, XX yes. You remember that. And if you do this homework today, this week, then when you get to 10 and 11, it's okay for you to just go XX yes on both of them.
There's another one like this on number 11.
Don't do it this week. If you wait till next week, you can't use that little hint of XX yes. on problems 10 and 11. Let's do number 11 now. Now I'm joking. How can I stop you? If you remember, it's XXS. I think this is the last one of these, so it's going to have to be the hardest one. It sure looks bad, doesn't it? The cube root of 6x plus 7.
Oh, I wanted to make it bigger. I guess I only made it worse.
Yeah. And g of x is 1/6 x to the third minus 7 over 6. So, first thing we're doing is f of g of x. We sort of have an advantage in that we know the answer is going to be, well, I told y'all, x.
If they're inverses, it's going to be
But
x. Maybe it is, and maybe it won't. You know, they could have changed the program, Tony.
Not if I'm doing it in my head correctly. So f of g of x. That means plug g into f. So plug all of this. Ooh, it's going to be messy. Into that. So in place of that blue x, it's going to be big. In place of that blue x, I'm going to have that, all of this red stuff, and I still have that blue plus 7. Ooh. So, put a 1/6 x to the third minus 7/6.
I think once we multiply the 6, I think things are going to start looking a lot better. Distributing that 6, what's going to happen? They're going to cancel those fractions, aren't they?
Yeah, the fractions are about to cancel. The 1 over 6 times 6. So we just have that x to the third.
And what are we going to have here?
Minus, what about the 6 times 7 over 6? Do the 6's cancel there? Yes. And we still have this blue plus 7 over here. That's going to keep on canceling nicely. The 7's, are they gone? Negative 7 plus 7, that's 0, so those subtract out. Something else is going to cancel, something that we did, oh gosh, second week of the semester, I think. It's about a cube root and a cube. Just like a square root and a square cancel out. A cube root and a cube, will those cancel?
Mm-hmm.
Leaving us just that red x as the answer. So it's going to be XXS.
Well, go ahead and show what.
I'm going to show it. I'm going to go through. By the way, what Pearson's working on now, and they have already started it in trigonometry, is, and I guess you've never taught one of those trig classes, where you're typing in every step, okay? And so you don't just type in that final answer. So going back to that old thing about things could always be worse, yeah.
Well, they were working. Have you all ever done the little writing with your mouse? There's apps where you can get the little and write with your mouse and stuff. They were working so that you would show your work writing with the mouse. And I think they've abandoned that, okay? Because it was just too.
There's a way we can make them show work.
I know.
But you just take a picture of it with your phone, upload it there, and then as a teacher, the teacher's got to look at the work. Not, our mother used to say, not no, but
blank no.
No. You know, and there's no way I'd have y'all doing that. And me looking at y'all's pictures to see the work.
And that wasn't Mama, that was Daddy.
Yeah, that's Daddy. That. Yeah, mother's. Okay, so G of f of x. Okay, let's do these arrows for the last time.
Last one. I think I've got the hang of these arrows. I've heard Tony's students talk about the arrows, and I've never seen it done like this. Okay, so here goes. So we're going to take f of x, and we're going to plug it into G. So we're going to take f of x and plug it in over here into G of x. So we have that green that red 1/6. We have that cube and that minus 7/6. And I'm moving up a little. And what am I going to write here? That cube root, that blue stuff. And one thing's about to cancel out immediately. What's about to cancel out? Okay, good. The cube and the cube root. So we just have 1/6. And all we have left here is that 6x plus 7 minus 7/6.
You have an idea of what the answer is going to be.
When I distribute this 1/6 there and there, 1/6 times 6x, what am I going to be left with? Just the x, I agree, plus 1/6 times 7 is 7 over 6, and look at this. We have that minus 7 over 6, and what do we conclude? That's about to happen here. Okay, they subtracted out, they're gone, leaving us only the x. So sure enough, the compositions reduce to x in both directions.
In a few weeks' time, I'll be trying to get y'all to remember the XXS problems.
That'll be after spring break, after the second test. I don't think they're going to. No. Heck, I probably won't.
I only put 13 problems on this assignment instead of 15 because the next two are cut points. So 2 cut points, very basic cut points. Go through all of those. So there's your cut points, denominator cut points, so forth. So,
So during spring break, if you're not caught up to homework, if you're not ready to start homework 13, get caught up and work on homework 13, and don't bother with homework 14. That's what we're doing after spring break. But you can start working that review for test 2. You can start doing that.
I think you can probably do the practice
for the at-home quiz also.
I'm not sure.
You have plenty of stuff to keep you out of trouble if you're at home or at the library. Well, I guess the library's closed, isn't it?
Yeah.
Off doing your homework, then you'll stay out of trouble.
But wait, your first priority is to plant the crops.
Oh yeah, that's right.
That's the purpose of spring break. Clear the fields, plant the crops.
Most of the students were males back then when spring break was invented. They had to go home to help their parents burn the field and plant the crops. That was the purpose of spring break.
So if you don't have any plants or crops to plant or fields to clear, your first thing should be get caught up on homework. And I don't mean just algebra homework, any of your other homework. Then you have fun. Okay? So having fun is last. After clear the fields, plant the crops, do your homework, then have fun. Okay?
Y'all be careful. Be careful.
Don't forget to come back.
It's like one day left. That's go to Starbucks or something.
Y'all have a good spring break.
Oh, no. Let me go ahead and stop it.